Greetings, everyone. I want to go over the solutions to the first practice exam. So we're given a differential equation, dy over dt equals negative 0.02 y squared, and we're told that this is from a chemical reaction and that the amount of the substance that we're measuring through this reaction at t equals 0 is 10 grams. And at first, they want us to estimate the amount of the substance at t equals 2 um, using a tangent line at t equals 0. And so we should remember that the equation of a tangent line looks like this. And then we're given most of the data here. We're given that a is going to be 0. And then if we know a is 0, then f of a is going to be 10. And so we just need to find the slope. And since the slope is given right up here as our differential equation, we just got to be careful that we're evaluating the differential equation at a particular y value. So we're not going to plug in 0 because t equals 0. We're going to plug in the y value at t equals 0, which is 10, and then we'll be able to calculate the slope. So dy over dt at t equals 0 is going to be negative 0.02 times 10 squared, since 10 is the y value. 10 squared is 100. 100 just moves the decimal place twice, of course, so we'll get a slope of negative 2. That's 1 point of the 2 points for this problem. Writing the equation is not a they don't give a value or a point for writing the equation. 1 point for the slope and 1 point for the final answer. So we're doing this at t equals 2, so I actually should probably put that right over here. And so we're going to plug in 2, and we're going to, whoops, plus 10. And from there we get 6. So, you may want to write a sentence, especially that we're going to be typing stuff in, typing out a quick sentence to make sure the answer is clear, what you intended. But that's the answer for the first one. It's 2 points. You get a point for the slope and a point for the value. Now for part B of this question, I'm not going to show the picture. I'm just going to do a quick little sketch. They ask, is it possible for the graph, which looks something like this is a poor representation of it, to be a solution to this differential equation? And remember, the differential equation looks like this. And so they want you to look at the qualities of this graph based on what the qualities we would expect from this graph to be. Now, if you look at the values here, no matter what value you plug in for y, we're going to end up squaring it. So it's going to be non-negative. And then we're going to be multiplying it by a negative quantity. So dy over dt is going to be less than or equal to 0 for all y. It looks like Allie, for all y. And if that's true, that means the graph has to always be decreasing. And obviously, there's a portion of the graph over here where the graph starts to increase. And so this graph here cannot be a solution to the differential equation. So the answer to this question is no. It's only a 1 point question, and you have to say no, and you have to explain why. And the explanation, again, is something relating to the fact that the derivative is always less than or equal to 0. Therefore, the graph of a solution has to be always decreasing, and this graph has a portion that is increasing. The next part C, which is 4 points, is to solve the differential equation given with the initial condition that was given. So, and t of 0, t of 0 and y of 10 correspond to a solution here. And so this is a separable differential equation. And so we got to bring the y's to one side and the x's to the other. Now, the negative 0.02 is a constant. You could leave it on the right-hand side. You could bring it along on the left-hand side. It doesn't really matter where you put it as long as you handle it properly. And there were a few people who didn't quite handle it very well. But nonetheless, I'm going to leave it over here. Just, again, mathematically, you just got to do what's correct. Some people who didn't handle it well moved it over here and then somehow when taking the reciprocal of the y term because of the negative exponent that's still on uh, the antiderivative, they moved the negative 0.02 to the numerator with it when it's that exponent doesn't apply to the constant, it only applies to the variable. Nonetheless, there are some issues to deal with. Some of you brought the y squared over but didn't put it in the denominator, so you didn't divide both sides by y squared. That's another issue. You get 1 point for separating the variables. So that right there is 1 point. And then we need our antiderivative step. You don't get a point separate for that, but it's just clear in your work. This becomes -1 over y. And then over here we get negative 0.02 t plus c. Some of you switch to x. I don't think they would penalize you for that, but you should try to stick to the letters that they give you. I mean, some of you wrote dx over here, and so it's natural then if you put dx over here, then you want to continue with x, but it's probably better to stick with the variables that they gave you as opposed to changing them to your own. Unless you explicitly state, I'm going to let t be x, and then it's clear and you can do that with no problem. Remember, we have this solution point over here, so -1/10 is going to be equal to negative 0.02 times 0 plus c, so that means c is just going to be -1/10. In my version here, if you move the negative 0.02 to a different side or to the other side or did something different with it, then you'd get a different c value, but that doesn't mean your answer is wrong. It just means that the arithmetic that you've done causes a different looking constant to pop out, but when you put it all back together, it's going to be mathematically equivalent. Again, assuming you did everything correctly. One other thing, if you don't have your plus C right here, it says the maximum you can earn is 2 points for this 4-point part here. By the way, so 1 point for the separation of variables, 1 point for the antiderivatives, 1 point for C and finding C, and then 1 point for solving for Y. So if you don't put a C, plus C here, then you're done. You can't get any more points. So just be careful for that. Now, the last step is to solve for Y. Now, some people made the mistake. They knew to take a reciprocal here, and so they just thought, I'll take a reciprocal here and separately take a reciprocal here. You can't do that, okay? So if I have A is equal, or 1 over A, let's say, I'm sorry, let's do it this way. 1 over A equal to 1 over B plus 1 over C, it is not true that that is equal to this, okay? Mathematically, that is not the same, and you can plug in some numbers to test that out for yourself, but some of you did that, and that's, bad. So, by the way, since everything's negative here, we can just, before I even do anything, I'm just going to change all the signs so I don't have to deal with the negatives. Now, if I do take a reciprocal on this side, then I take the reciprocal of the whole thing like this. Now, if you want to do some mathematics to rewrite this, you can, but why bother? This is mathematically correct. It's equivalent to this is the answer actually they give in the solution, but some of you got, I can't remember, it's like 50 over t plus 5, I think, and it's equivalent to this. If you multiply through by 50 in the numerator and denominator, you're going to get 5 over here, and yeah, this is 1/50th, I believe. So, that's the way you can do it. And then I don't remember part D, so I'm going to pause it, go look at part D, and then I'll come back and finish. So D asks you to determine whether the amount of substance is changing at an increasing or decreasing rate. And that's where some of you made the mistake. Some of you just looked at dy over dt and said, well, dy over dt is negative, so it's got to be decreasing. And that is incorrect, okay? Because they're not asking you, is the amount increasing or decreasing? They're asking you, is it increasing or decreasing at is the amount increasing or decreasing at a decreasing or increasing rate. I'm sorry, I'm saying it wrong because it's not right in front of me, but what we need to do is we need to take the second derivative and see if the second derivative is positive or negative. Actually, I need this here. And so we have this. So when I go to take the second derivative, when I differentiate both sides with respect to t, I'm going to get negative 0.02 times dy over dt. And no, I copied this down wrong. I'm sorry. That should be squared right there. So let me fix this. Sorry. So this is going to be times 2y times dy over dt. And then if we substitute in over here, dy over dt is negative 0.02 y squared. We're going to find out, so the negative times negative is a positive times 2. And really, if you don't want to do the arithmetic here, you don't have to. You can just leave it all like this, because that's true. Okay, we're talking about the amount of a substance, so that means y has to be a positive number. Actually, none. Could be 0. Let's just assume it's positive for now. That's what they do in their solutions. There might be something to indicate that. Yeah, well, because it starts off at a positive amount, and it's the derivative is always, well, that's negative, always decreasing. I don't think it ever, I think it asymptotically gets closer to 0. I apologize for not thinking through the reasoning on this, but if y is positive, then dy over dt is also going to be positive, because this is going to be greater than 0, and all this is positive over here. I'm sorry, this should be the second derivative. Going too fast. And therefore, this is going to be at an increasing rate, because the second derivative is greater than 0. A little sloppy. I'll try to do the second 2 questions a little bit better. But I'm going to pause and go look at those. All right, here's the next question. I'm gonna just I'll show you here, and then I'll switch back over to the notes. So it says the function g is defined on the closed interval negative 4, 8. The graph consists of 2 linear pieces and a semicircle as shown in the figure above. Let f be a function defined by f of x, which is 3x plus the integral from 0 to x of g of t dt. And again, we're looking at the graph of g. So we want to find f of 7 and f of negative 7. So f of x being 3x plus the integral something to x of g of t dt. I don't remember where we start that from. We'll start from 0. So f of 7 is going to be 3 times 7 plus the integral from 0 to 7 of g of t dt. And the purpose of this graph here, or this problem, is to have you analyze this geometrically. Okay, so this is going to be 21 plus whatever we get out of the geometry of looking at this picture from 0 to 7. So from 0 to 7, we have two regions defined with 2 different curves. We have this semicircle that's below the axis here, and then we have a horizontal line between 6 and 7. Now, some of you didn't count the semicircle area as negative, but you should have, because it's below the horizontal axis, and so some of you got it wrong for that reason. This little part over here is just, 3 times 1, so that's 3. The radius of the semicircle is 3, and so the area is going to be 3 squared times pi, but we got to take half of that because it's a semicircle and make it negative because it's below, plus the positive 3 there. So you can literally stop right there as your answer, but if you want to simplify it, you can. I generally don't tell you not to worry about that, because if you do make a mistake, they will penalize you for it. And this is correct, and they'll give you credit for that. Now we want f prime of 7. Now if you just look at the function up here, the derivative of 3x, of course, is 3. And by the fundamental theorem, which they love to use and see if you understand it, the derivative of the integral part is just going to be g of x. I should call this f prime of x for a moment, and then f prime of 7 is going to be 3 plus g of 7. So I'm just going to go read g of 7 from the graph. G of 7 is 3, so this is going to be 3 plus 3, which is, of course, 6. So that's part A. For part B, it says find the value of x in the closed interval negative 4, 3, which f attains its maximum value. Some of you went beyond -4, 3. Some of you looked at 8 and 6 and other things. Pay attention to the intervals, the interval on which they're asking you to do the analysis, because you get it wrong if you're looking in the wrong spot automatically. I mean, you might get some partial credit for some of the work that you do, but by the way, question number 1, or A, for this was 2 points, 1 point for each piece. B is also a 2-point question, if I'm remembering correctly. And so we could use the closed interval method because we're looking on a closed interval. They do something a little bit different, though. I'm trying to remember what they did in their solutions, but it's not coming to me. But anyways, let's take f prime, and we're going to set it equal to 0. And so we get g of x has to be equal to -3 to make that true. And g of x equals -3 at 3. So that happens to be an endpoint. I'm sorry, I'm stuck on trying to remember what they did. They did something about saying that the graph f prime is always positive, so I think, but I don't remember. So most of you did it this way anyways, which I liked. So 3 is an endpoint, -4 is an endpoint, so we need to calculate f of -4 and f of 3, and then we do that, and we can compare and see which one, or see where the maximum occurs. Now, f of -4 is going to be 3 times 4 plus the integral from 0 to -4. Notice that that's backwards. Let me zoom in a little. -4 of g of t dt. Sorry, my dog's now wanting attention. All right, you might hear some barking in the background. So there you go. 12 minus the integral from -4 to 0. I'm going to flip the limits of integration and get this, and then 12 minus. Now the area from -4 to 0, so we got 4. It's a triangle, so we got 4 there times 2 vertically, and then got to take half of that, and so that's going to be minus 4 times 2 divided by 2, which is just 4, so this is going to be 8. And at 3, this is going to be 3 times 3 plus the integral from 0 to 3 of g of t dt, which is 9 plus, now we're dealing with a quarter circle. So we'll have to subtract, so it's going to be 9/4 pi. And now I'm noticing that this should be 3 times -4 right over here. And so this should be -12, and this should be -16. So sorry about my typo. So now this is a positive number. This is a negative number. So clearly the max occurs. I can't even write this morning. Occurs at x equals 3. They don't ask for the actual maximum, they ask for the x coordinates. That's how you should answer it. Again, that's a 2-point question. All right, let's take a look at part C. It's wanting to find two limits as x approaches 0 from the left and 0 from the right for g prime. Now, not f prime, for g prime. And a lot of people have made mistakes on this one. Limit as x approaches 0 from the right for g prime of x, and from the left, or that's from the left, and from the right. All right, let's go up here and take a look at g prime for a moment. Okay, or we can't see g prime. Let's take a look at g, and then we'll figure out what's going on with g prime. Now, from the left, okay, this is g. G is linear, so its derivative, g prime, is just going to be the slope of that line. And what's the slope of that line? It's -1/2. A lot of you put positive 1/2, and others did some other silly things. I don't know. From the right, it's going to be the slope of the circle at this point here, but the circle at its endpoints has a vertical tangent line, the semicircle there. And so this is going to be, this is not going to exist because the tangent line goes vertical. Vertical lines don't have a slope. So those are 1 point each, and it was easier than I thought. Some of you made it by the work that you did or what you said. Now for letter D, we're taking a limit as x approaches -2. Not all the time, but often when you're looking at a limit on the free response questions, you're looking at, you should be thinking about L'Hopital's rule. It's not 100%, but it does happen a lot. So have L'Hopital's jump into your mind, and at the very least, even if you apply it incorrectly, if you do L'Hopital's rule, they'll give you a point. So if you try direct substitution, if you look at each of these separately, and they do want you to take a look at them, at least acknowledge that you get zeros for each, and you do. So I'm going to look at the numerator separately for a moment. This is going to be f of -2 plus 7, or the integral from 0 to -2 of g of t dt plus 7. And then if you go look at that from integral from, we got to flip it over, but from 0 to -2, we have, what is this? We're going over, yeah, so it's going 1 here times 2 there, and I'm sorry, I'm just checking my numbers here. For some reason, I think I'm a little bit, something seems a little bit off here. And I don't know where. Oh, because I forgot the 3 times x part. I know I'm copied something down wrong. Plus 7 equals 3 times -2 plus, let's squeeze that in there. So this is going to be 6, -6, minus 1, because the area of that little triangle is 1, but because the limits of integration are reversed, we have to make it the opposite. So that comes out to be 0. And the limit of the denominator, now if I plug in -2 up here, I get 0, e to the 0 is 1, so we get 1 minus 1, which is 0. So that means you have to apply L'Hopital's rule. And when we apply L'Hopital's rule, we're going to get f prime of x over 3 times e to the 3x plus 6, f prime of -2, which is not 0. And if I plug -2 up here, this is going to end up being 3. Now, f prime of x, if we recall, is going to be 3 plus g of x. So this is going to be 3 plus g of -2. Now if you go back to your graph, g of -2 is 1, so this is going to be 1 plus 3 or 4 thirds. My dog's in the background here whining to go in the house. That was like a 3-point question. 1 point for getting those zeros, 1 point for doing L'Hopital's, and 1 point for the answer. A lot of points on something that is not that challenging. All right, for the third question, we're given this series, and for p equals 3 and x equals 8, does the series converge absolutely, conditionally, or does it diverge? Explain your reasoning. And so these typically, when they give you specific values at which to analyze this, it's not a ratio test typically. What you want to do typically is use one of the other tests. Usually you'll be able to identify the series as a certain type, and you'll be able to apply that particular type. So if we plug in 3 for p and 8 for x, we're going to get 5 to the n up here. When I'm 8 minus 3 is 5, of course. Got 5 to the end down here, which is nice, and cubed over here. So when we simplify this a little bit, and we should be canceling these out. you end up with -1 to the n plus 1 over n cubed, like this. And this makes it much easier. You should identify this really as two different things, but both helpful to recognize. It's alternating because the -1 to the n plus 1, and it's also a p series. In a sense, it's an alternating p series, but we got n equals 3, so um, that should tell you something. Now, since they're looking for absolute convergence, I would try to do this with, by definition of absolute convergence. I would take a look at the magnitude of this and see if I can get this to converge. Because if this converges, then I know the original series will converge. That's the easiest way to approach this. You could do the alternating series test on this, but then that only tells you that at best gives you conditional convergence. It doesn't give you absolute convergence. So you would still have more work to do. If I do it this way, I get a p series, and this is a convergent p series with p equal to 3, which is greater than 1. Okay, that means the series converges absolutely. Again, you should write a sentence. I'm going to be lazy and just write absolute convergence here. But that's the easiest way to handle this one, because again, if you do the alternating series test, you know that it's convergent, but it could still be conditionally convergent. You have more work to do to show absolute convergence. So there's that. For part B, it says now p equals 1 and x equals 8. Same question. Yeah, make sure I got this right. So -1 to the n plus 1. We get our 5 to the n. We get 5 to the n. And now it's just times n over here. And when we do this, you should recognize this as the alternating harmonic series. Okay. This is the alternating harmonic series. Which converges by the alternating series test. And you could show that really quickly by taking a look at the limit as n approaches infinity of 1 over n. That goes to 0. And then you could do n plus 1 is going to be greater than n. So 1 over n plus 1 is going to be less than 1 over n. So that means a sub n plus 1 is less than 1. Whoops, that should be a sub n. So you're showing the two parts of the alternating series test. Now, we're not done because that gives us convergence. We've got to take a look at the magnitude. If you would have done this first, and that would have been fine to do this first, you still would have had more work to do. This is the harmonic series when you take the magnitude, which diverges. And all you have to do is state that. And if you state that and what we showed up there, then we've shown conditional convergence. Conditional convergence. So that's what you were supposed to show for part B. Usually they're not going to give you a question where both behave the same. So if they're asking the same question under two different circumstances, the likelihood that you're going to get both absolute convergence or both conditional convergence is really small. They're trying to see if you can identify differences. So if you end up with the same thing for both answers, then you probably made a mistake somewhere. At x equals -2, for what value of p does the series converge? Explain your reasoning. I don't remember the point values off the top of my head for these. I think those are each 2 points at the beginning, but I'm not certain. We get -1 to the n. And then this time it said p is equal to -2, which gives us -5 to the n here, 5 to the n times n to the p. This should be n plus 1 up here. It's a little typo. I'm writing too fast. Now, with this negative 5 to the n, we should separate this out a little bit. So this is negative 1 to the n plus 1. And then we're going to end up with negative 1 to the n times 5 to the n. I'm just using a basic exponent property from, exponent law from, middle school, whenever you learned it. If I have a times b to the power of x, that's a to the x times b to the x. That's all I did here is there's a negative 1 times 5 in here, so I'm just applying the exponent n to each factor. And then from there, we can cancel these out here. Now, if we take a look and think about what happens here, because we're raising negative 1 to n, negative 1 to the n plus 1, actually, I was going to do this one way. I'm going to explain this slightly differently. Negative 1 than I originally had in my head here. We have two numbers with the same base. Raised to some powers. How do we simplify them? We simplify their exponents like this by adding the exponents together. So n plus 1 plus n is going to be 2n plus 1. What kind of number is 2n plus 1? Well, since n's an integer, positive integer from 1 to infinity, 2 times n is going to be an even number plus 1 is going to be an odd number. So this is always odd. And if I raise negative 1 to an odd number, this is always going to be negative 1. So then my series becomes always negative 1 on top over n to the power of p. I could factor out that negative 1 in front of the series here like this, and I get 1 over n to the p. And this is just the opposite of a p-series. When does a p-series converge? This is going to converge when p is greater than 1, because it's just a p-series multiplied by a negative. P-series converge when p is greater than 1. So there you go. I'm going to pause, and I'll be back in a moment. All right, for part D, it says when p equals 1 and x equals 3.1, the series converges to a value s. So it means we don't have to prove convergence. They're telling us that. Use the first two terms of the series to approximate s. That's the first part. Use alternating series error bound to show that this approximation differs from s by less than 1 over 300,000. All right, so back over here, we have our sum from n equals 1 to infinity, negative 1 to the n plus 1. Now we're going to plug in 3.1, so it's 3.1 minus 3, so we're going to get 0.1 raised to the power of n, and then divided by 5 to the n times n to the first power, because p is equal to 1. So this is what we're dealing with here. Now they're telling us to use the first two terms to approximate the series. So the series s is approximated by s of 2, which is literally all you got to do is plug in 1 and plug in 2 to the general term here, and combine them, and that's your answer for the first part. So I plug in 1. I'm going to get negative 1 to the second power, so it's going to be positive. And I get 0.1 to the first power over 5. And then if I plug in 2, then I'm going to get a negative, because I'm going to have 3 as the exponent, so it's going to be minus. And then I'm going to have 0.1 squared over 5 squared times 2, which is just 50. Literally, you could stop there. If you want to simplify it, you can, but that's the first part. Okay, so s is approximated by the first two terms of the series. Now we got to show that this differs from s by less than 1 over 300,000 using the alternating series estimation theorem. The alternating series estimation theorem says that the magnitude of the error bound for the nth partial sum is bounded by the n plus first term for the alternating series. Now we're finding the second partial sum, so that means this is going to be less than or equal to a sub 3. Okay, now a sub 3 is this term with 3 in it, okay? And we'll ignore the magnitude, or we'll make rather we'll ignore negative and make it a magnitude. But it doesn't matter because 3 plus 1 is 4, so it's going to become positive anyways. But we're going to end up with 0.1 cubed over 5 cubed times 3, and then you just got to show if this number is smaller than 1 over 300,000. So just basically simplify it as a fraction until you get and can state that that's in fact true. So 1 over 10 cubed, that's 0.1, okay? This is 125, 5 cubed is 125 times 3 is going to be 375. And so this becomes 1 over 1,000 times 1 over 375, which is just 1 over 375 followed by 3 zeros. And that is clearly smaller than 1 over 300,000. And that's it. That's all you had to do for that second part. And typically, finding the approximations with the error bounds are pretty straightforward like that. All right, go study.